Hello, everyone. Good morning or afternoon, wherever you may be joining us. Thank you for joining our webinar presented by Sekisui SPR Americas. My name is Ryan Schallenberger, and I will be moderating this event. This presentation will cover spiral wound liners, a trenchless pipe rehabilitation technology for gravity pipe applications. Our two presenters today are Jackie Jaquez and Chris Lind. I'll give a quick bio on both of our presenters before we start. Jackie is the regional manager for Sekisui SPR Americas for the Western United States. She has over 25 years of industry experience working with manufacturers, contractors, specializing in trenchless pipeline rehabilitation and condition assessment solutions. She is a current board member of WEST and is active in numerous industry committees. Chris is the regional manager for Sekisui SPR Americas for the Eastern United States. He has over 12 years of industry experience working with manufacturers, distributors, and contractors specializing in pump technology and trenchless pipeline rehabilitation. He is a current member of NASCO and NAST and has presented at regional conferences. Now, before we get started, there's a few housekeeping items that I'll need to cover. This will be a 45-minute presentation with a total of 15 minutes per question and answer. There will be a 5-minute Q&A session intermission during the middle of this presentation and a 10-minute Q&A after the presentation. Please write in your answers at any point, and we will quickly cover how to do so on the next slide. In this picture, you can see there's a portal to ask questions. Simply click Ask a Question to do so. If this portal is not visible, click the symbol where the red arrow is pointing. This should make the Q&A window available. Again, please remember to ask your questions at any point during this presentation. And with that, I'll pass it over to Chris Lind.
Thank you, Ryan, and thank you for everyone for taking time out of their schedules for the webinar. As you can see from our outline, we're going to be covering 5 different topics for our spiral wound presentation. The first will be our spiral wound basics, and then also I'll be working on design considerations when we get your projects in the field and what we look for to be able to construct a spiral wound design for you. Jackie will go ahead and kick in with the features and benefits of our product, as well as typical installation processes. And then finally, we'll talk about some case studies that we've had some success with over the years with our product. So starting off, with over 4 million feet installed in the United States for nearly 30 years, spiral wound liners for rehabilitation are not a new technology. Spiral wound liners are capable of rehabilitating gravity sanitary sewer, storm drain, and culvert pipelines. Mechanical installation equipment placed inside of the hose pipe winds the manufactured PVC profile to form a liner. Each liner is designed to form a fully structural solution, and SPR offers 3 different products to cover a range of round and non-round pipelines with varying diameters, which we will discuss in further detail later in the presentation. So let's talk briefly about the spiral wound process. All of our spiral wound products utilize a specific winding machine to form our liners. Each machine is specific to the diameter and shape of the hose pipe. The machines can be locked into position to form the liner, which we call static winding, or the machine can travel inside the pipe to create the liner, which we call traverse winding. Finally, the machinery that is used allows the liner to be a tight fit against the hose pipe, or leaves an annular space that will be filled with a grout. The decision of whether to use a tight fit or grouted solution will be discussed later in the presentation. The PVC profile strip that you see in the picture is manufactured so that upon installation, a continuously sealed spiral joint is formed. The machinery in our factory fabricates these strips and is sent to our installers on spools for installation in the field. When the application for your project demands it, the profile strip can be reinforced with steel at the factory so that additional work does not have to be done in the field. The spool that arrives in the field to our installers is mounted on hydraulically powered spool skates, allowing the profile to be fed directly into the manhole, where the winding machinery is positioned to form the liner. With the completion of the installation of the liner, a grouting of the annular space when necessary, reinstating any lateral connections, and sealing each end of the liner, you can expect that you will have a completely sealed, fully structural pipe that is able to stand up to all loading without benefit from the hose pipe. The installed liner will also provide hydraulic efficiencies that match or exceed the current flow characteristics of the deteriorated hose pipe. Finally, it is designed for a minimum of 50-year service life. The PVC profile manufactured by our factories in Japan and Australia and the Netherlands serve as the building block for all of our spiral wound rehabilitation products. The compounds used in the PVC profile meet the minimum cell classifications within ASTM F1697-18. All of our PVC profiles are manufactured in configurations that create the mechanical locks of our spiral wound systems. The mechanical locks of the PVC profile are then enhanced with sealing materials that, when compressed by the locks, form a watertight structure. When the design and loading for a rehabilitation project require additional strength for a project application, the PVC profile can include additional steel reinforcement or manufactured in a manner so that the SPR liner formed can be expanded to form a tight fit against the hose pipe. There are many similarities associated with the equipment used for the installation of our spiral wound liners. The equipment is lowered through the existing manhole or access point to the invert of the pipe. The material is fed from spools above the manhole to the lining equipment. Once the material reaches the winding equipment, the liner can be formed by two different methods. First is static winding. During static winding, the equipment is locked in place at the entry of the line segment. Then the PVC profile is fed into the equipment, which forms the liner and pushes it from one manhole to the next. The other method is traverse winding. During traverse winding, the equipment is set up inside of the entry of the line segment. The PVC profile is fed into the equipment. The equipment travels inside of the hose pipe while pulling the material into place to form the liner. The use of static winding versus traverse winding is determined by the length, diameter, shape, and condition of the current hose pipe. Now that we've covered some of the basics of the spiral wound process, let's talk about how our liners are designed and the variables that must be considered when we look at one of your projects. All of our spiral wound lining solutions meet and adhere to standards and specifications that have been established by agencies and organizations worldwide. The first, which is ASTM 1697-18, and the second, ASTM F1741-18. As we work with our installers and their customers for spiral wound rehabilitation, one of the first questions we must get answered is the condition of the existing hose pipe. In most cases, through line assessments, it has been determined that the pipe is in a condition where it is at or close to the end of its useful life. Under these types of hose pipe conditions, our designs will be done to meet the fully deteriorated standard under ASTM F1741-18. The resulting liner from the design work that will be installed will be able to withstand all existing loads, from the active soil conditions to additional live loading created by highways, railroads, or airlines, and the hydrostatic loading created by groundwater above the level of the pipeline. The finished liner will not need any contribution from the hose pipe to meet this standard. There are instances when we are asked to provide the design for a liner when perhaps the hose pipe still has usable life. In many of these instances, corrosion protection for the existing hose pipe to extend its life is the goal. In this situation, the liner that is designed according to the partially deteriorated standard under the same ASTM is to handle the hydrostatic load generated by the water table while the hose pipe is still able to handle the remainder of the load. When designing to this standard, it is very important to understand the nature of the hydrostatic load. So it is necessary to consider times of the year when the water table is high and low and account for those differences to determine the final design of the spiral wound liner. Finally, built within the ASTM is a consideration for non-round and very large diameter pipes. In these applications, it is best to consult with us to identify all the characteristics of these types of pipes and determine whether the spiral wound rehabilitation might have to include additional reinforcement measures. That is all for the basics of the spiral wound process and considerations necessary when designing our spiral wound liners for your applications. I'm going to turn it over to Jackie so that she can talk to you specifically about the features and benefits of our products, as well as their use in typical installations.
Great, thank you, Chris, and welcome everyone. We appreciate your time today. We're going to get into the features and benefits of our spiral wound liners, and many of you are very familiar with our products and capabilities. First of all, Sekisui's liners have been tested in accordance with international standards to determine we have a Manning's coefficient of 0.009. That means that even though post-rehabilitation the pipe has been reduced in diameter, we typically can equate, if not improve, the hydraulics due to the improved Manning's coefficient. Next, corrosion and chemical resistance, very important for a product that is used in a sanitary sewer environment. Our materials include pipe-grade PVC that have excellent resistance to hydrogen sulfide corrosion and other corrosive elements that would be found in a sanitary sewer. Not only do we meet the ASTM standards for testing, but also regional standards such as the Green Book, which are far more stringent than the national standards. PVC lock integrity, that means our mechanical lock will provide a continuous tight seal impervious to water or root intrusion throughout the entire length of the installation. The lock integrity testing was done at Ramtech Labs here in the United States to replicate the tests that have been done internationally prior. All these tests were done by Ramtech under the viewing of many agencies in Southern California, including the City of Los Angeles, LA County Sanitation District, and the City of San Diego, just to name a few. The testing that was done included the straight alignment test, axial misalignment, and shear deflection per these parameters on unsupported pipe. The duration was for 10 minutes, and based on the successful testing, our liners were included in the Green Book Section 500, Pipeline Rehabilitation, in 1998. Structural integrity, very important. As Chris outlined, we can design a fully structural liner capable of withstanding all applied loads for your project application. Furthermore, as a global company with a lot of our projects being in seismic sensitive areas, our Japanese engineers have conducted a lot of testing on our liners, and that we found that our liners are definitely earthquake resistant and can still withstand a 50-year design life when designed in accordance with the standards and plans. Another great feature of our system is little to no bypass. We say anywhere from 20 to 30% full pipe is allowable based on the pipe diameter, slope, and just the overall pipe conditions, and we'll be able to make that assessment based on your individual project. Furthermore, there's no site excavation. The installation equipment was specifically designed in order to be 100% trenchless. We can install all of our equipment through an existing access point without any type of site excavation or access pits, and all the construction is done through the existing access chamber. It's a very big benefit, particularly when you're dealing with a very crowded residential or urban area. And again, too, if you're dealing in an environmentally sensitive area, we're not going to be disrupting the area. The mechanical installation process is very important. First of all, we're an ISO 9001 manufacturing facility, and our processes are all compliant with these standards. That means you get a consistent profile, material, and dimensions of this material when it's shipped to your project site. The site conditions will not impact liner quality. And because there's no chemicals or thermal processes on site, you're not going to have any deviations to the material or post-installation non-compliances. And again, very important, we are an environmentally friendly technology. There's no styrene or VOCs. There's no unpleasant odor. There's no wastewater or waste products. Minimal operating construction site footprint. All very important when you're dealing with environmentally sensitive areas, or let's say you're working near a school or a hospital or residential areas. These all are very important, and when combined, this makes the Sekisui liners very advantageous when you're considering it for your client project. And with that, I'm going to turn it back to Ryan. We're going to do a quick 5-minute Q&A here, and we look forward to your questions.
All right, thank you, Jackie. Yes, and thank you for everyone who's inputted a question so far. And our first question is, what is the maximum internal pressure spiral wound can handle, or is this only for gravity sewers?
Thanks, Ryan. I'll take that question. Basically, and bottom line, spiral wound liners are for gravity sewer applications only.
Great, thank you, Chris. The next question is, how much reduction in hydraulic capacity can you expect using spiral wound liners?
I can take that, Ryan. Due to the improved Manning's coefficient of 0.009, our Sekisui PVC liners can typically equate if not improve flow capacity post-rehabilitation. Our design calculations will include this information in the design summary to verify our liner design can meet specific hydraulic requirements.
Great, thank you, Jackie. And we were just talking about installation in live flow. When would it be necessary to include flow bypassing? Can other flow management options be considered as well?
Sure, absolutely. Spiral wound liners can typically be installed in live flow, up to 30% full pipe with smaller diameter rehabilitation, and 20 to 25% with larger diameter rehabilitation. Flow velocity and slope have to be considered into decisions when flow conditions meet or exceed man entry safety requirements. And we want the work crews to be as safe as possible when working within live flow. Before flow bypassing would be required, however, a contractor might utilize flow through plugs, weir wells, as well as installing liners at night during non-traditional working hours to manage those low flow conditions.
All right, thank you, Chris. I think we have time for a few more questions in this intermission. What are the maximum run lengths that Sekisui spiral wound liners can handle?
I can take that, Ryan. The profile is delivered to the job site on spools, and depending on the profile, a standard spool can have anywhere from 500 meters to 5,850 meters. For SPR EX, run lengths can be done from 250 to 800 feet, depending on the pipe diameter. Due to the double locking configuration, subsequent spools of EX cannot currently be joined together. However, with SPR TF and SPR TM, longer run lengths can be done as spools can be joined. Typical run lengths are 700 to 1,000 feet. Longer runs can be done and will be evaluated on a project-by-project basis.
Great, thank you, Jackie. And kind of going along with that, do you need access to both ends of the run to do a spiral wound installation?
I can respond to that. Typically, yeah, especially for a smaller diameter, non-man entryable system, you definitely want to be able to have access at both locations. So just in general, the answer would be yes, but there are situations where we can evaluate it if we only had one point of access, but typically 2 points of access would be necessary.
Great, thank you, Jackie, and thank you for those who are inputting and submitting questions. That's all the time we have in this intermission, but remember, we'll be taking the rest of your questions right after this presentation. So please remember to keep on submitting your questions. And with that, I'll turn it back over to Jackie to continue the presentation.
All right, thank you, Ryan. So here in the typical installation, we want to give you an overview of our 3 different installation processes here to give you an idea of how we install our liners. Small construction footprint, as you can see. We've got it set up at 2 access chambers here. The first product is SPR RTF. This is for 6-inch through 42-inch diameters. This is a tight fit liner. We're going to install this liner initially at a smaller diameter, and we're going to wind from the downstream manhole structure to the upstream manhole structure. As you can see here, each subsequent stripper profile is interlocking with the wire that's positioned between the primary and secondary lock. So once the liner reaches the termination structure, the operator is going to retract that wire, sever the sacrificial lock, and now the liner wants to expand out to become a tight fit liner from manhole to manhole structure. Meanwhile, the operator will add additional profile into the hose pipe in order to pick up the slack from the expansion process. SPR TF is our next tight fit lining system, a little bit different here. So we're going to wind in with the flow for the SPR TF process here. As you can see here, the TF equipment here is a very compact, efficient method for tightly winding in the profile against the inside of the hose pipe. Again, this is a tight fit system and no annular space grouting is required. As you can see there, the factory installed gasketing material. And now we have here a secondary type of equipment here installing our liners. But again, we look at this from a project by project basis. This is the RO equipment within this family. And as you can see, the spring-loaded arms here are rotating around the inside of the hose pipe and tightly fitting the liner against the inside of the hose pipe. And again, we can install in live flow, as you can see from the demonstration. Finally, we have SPR TMO. This is our product that can be used for circular and non-circular shape-to-shape installations. As you can see here, we're demonstrating a rectangular installation. What's different here, it's also a traverse fit system here that is winding down the length of the pipeline, and it's actually creating a liner per a guide frame that's been established in the design calculations. It will continue winding down, and then we'll come back in and do annular space grouting. Typically, simple bracing is used. As demonstrating here, just conceptually here, we will reinforce the liner to prevent liner flotation during the installation process. And then the operator will come back in and perform annular space grouting. This can be done in a variety of different ways using structural or non-structural grouts and single to multi-lifts depending on the compressive strength of the grout, the project, the run length, etc. And that would be part of our submittals to our contractor. So basically, it's a very simple installation process here. Pre-installation, the pipe is clean and inspected. The laterals are logged as a result, so we know how to go back and reinstate them post-installation. As you saw from the videos, a strip-up profile is fed from a spool above the ground. It could be either on spool skates on the street or on the back of a truck. And the liner is constructed on site inside the hose pipe. Post-installation, which is great, we can go back and immediately reinstate laterals because we don't have to wait for the liner to cure. And all liners are automatically trimmed and end sealed using an approved end sealing method. Reinstating connections is very straightforward. We can reinstate existing laterals, as you can see in the upper left there. Just a standard cutter would go in and go to the location marked by the operator to reinstate it. We can also come in and man-entryable and mark it pre-lining for the larger applications. As you can see on the lower right-hand side, it would be an SPR TM lateral reinstatement. Industry-wide, agencies can vary from having no SLCs to using a variety of top hats or other types of means and methods in order to seal the lateral post-installation. So the first product we'll get into some detail here is SPR EX. And as you saw from the video, this is a tight fit lining system for 6-inch through 42-inch circular pipelines, and it does not require annular space grouting. So the next picture you're seeing here is basically pre and post installation here as to how the lock would look before it's expanded. On the left is how the profile cross section would look as it's wound in. You've got the primary lock with a lubricating sealant that will cure up completely within several hours in order to form a secondary gasketing material. In the secondary or sacrificial lock, it's basically a locking configuration that will be severed once it's expanded. So on the right, you see the cross section here. The wire has been pulled, and you've got a very smooth inner surface that actually will help improve hydraulics post installation. Another great feature of our technology is live monitoring of the installation process. On the right, you've got the profile truck. The operator there is able to enter in all the data for the particular run length, the hose pipe diameter, the pipe material, other conditions, the speed by which he wants to wind in the liner, the placement of a lubricating sealant in that primary lock, etc. And on the left, you've got the CCTV truck that is waiting for the liner to be received at the termination structure, and then he would also be doing the live lateral reinstatement once the liner has been installed. And for any reason that they have to stop, let's say that there is an adjustment required, we can stop the installation process, modify the speed, change whatever we need to do, and then continue without damaging the installation or the liner. Next, we have SPR TF. This is a traverse winding system, and this is our newest product into the Sekisui family for 40 through 60-inch circular pipelines. So as you can see, this is another tight fit lining solution that does not require annular space grouting. Little different than the EX system, which was stationary within the hose pipe here. You now have a traverse fit system. The Sekisui engineers developed this technology because they believed that we could get longer run lengths and a tighter fit by having a hydraulically powered traverse system in order to install at this diameter range. We have a wide variety of profiles within the SPR TF family, which include steel reinforced profiles that can do a wider range of applications and depths for various types of projects. So on the left here, we have the SPR TF method. Very compact and installs PVC profiles. The same profiles can also be installed with our own machine on the right, which also is typically used for the profiles that have steel reinforcement.
I'm going to go ahead and jump back in.
We've got SPR TM, and with that, I'm going to turn it over to Chris for his input on SPR TM.
Thanks, Jackie. When considering the use of our fixed diameter liners, the diameter of the hose pipe will determine whether we will utilize a static or traverse winding system. No matter the diameter, which in the case of the SPR method is anywhere from 32 inches to well over 200 inches, and the shape of the existing pipe, the winding equipment will leave an annular space between the liner and the hose pipe that must be filled with either a cellular or structural grout. As we discussed in the last slide, the SPR method is for custom pipe shapes and very large diameter line segments. As part of the installation process of these liners, the static or traverse winding equipment used will form the liner with the assistance of a manufactured guide frame, which will be in the shape of the hose pipe. Because there needs to be room for the winding equipment to move around the guide frame, generally 4 to 8 inches, an annular space is formed between the finished liner and the hose pipe. Due to the custom nature of the hose pipes rehabilitated by the SPR product, there are two different types of products that can be used. The first is what we consider to be straight profile. The second is a flexible profile. These profiles make it possible to mechanically wind not only straight sections of pipe, but also many of the large sweeping radius bends and siphons that make up many of the pipeline systems that are being rehabilitated. As I mentioned before, the SPR method for these types of custom rehabilitation will require a fully structural fixed diameter liner. Therefore, grouting will be required to fill the annular space between the liner and the hose pipe. But before selecting any of our lining products, we also need to determine when grouting is required. Grouting within a spiral wound rehabilitation is generally required when excessive sections of the hose pipe are missing, when separation between pipe joints of more than 12.5% of the ID are created, and when over time the original shape of the pipe has reached ovalities of greater than 5%. When grouting becomes a necessity, then it is time to determine the type of grout required for the lined hose pipe. As you can see on the left, when the design of the liner meets the ASTM for a fully deteriorated hose pipe, then the grouting for the annular space can be cellular, acting as a means of load transfer between the liner and the hose pipe. The liner installed in this situation will always be round, whether the hose pipe is non-round or round. When working with the design of a non-spiral wound liner inside of a non-round hose pipe, a structural grout will always be required, as depicted with the picture on the right. In both cases, the strength of the grout, cellular or structural, is determined by a professional engineer who will look not only at the strength of the liner, but also the loading conditions in making their recommendation. After selection and strength of the grout is determined, we will then work with the installer to select the best procedure for installing the grout in the annular space. After bulkheads are placed at the end of each liner in the rehabilitated segment, we will decide about the type of bracing system needed to support the liner and prevent it from floating during grouting. We will also need to determine the number of lifts, sometimes called elevations, of grout that are needed to fill the annular space. Using installed grout ports, our installers will be able to monitor the success of the grouting process by observing when water is no longer coming out of the ports and grout does. Once this occurs, the grout ports are capped until the lift is complete. This procedure continues until the entire annular space has been filled completely. Now that we have finished talking about the typical installations of SPR methods, I would like to turn it back over to Jackie as we review some successful rehabilitation projects from the past.
Thank you, Chris. All right, case studies. We have an extensive amount of work that's been done, especially here on the West Coast. We have well over 4 million feet of our liners installed. One of our big programs is for the city of San Diego. We have been installing liners in San Diego since about 2000. Initially when they got involved with their consent decree program, and to date we have over 1 million feet of our liners installed, and both of our licensees are actively working and have a pretty extensive backlog on projects that are currently under construction. We've also done a lot of work for LA County Department of Public Works. The county actually does maintenance services for 38 cities throughout LA County. And today we have over 750,000 feet of our liners installed, going back to the late 1990s. Now, I mentioned to you the environmental aspects of our liners are very important. This was a project for the city of Newport Beach in the Back Bay area. It was an ecological reserve. It originally had been specified with CIPP. The contractor was actually quite concerned about using a styrene-based lining solution in an area with open tidal waters with a potential for contamination. Our contractors, Vertec, New Line Technologies, were able to install our liners in open flow, did some tidal flow management, but there was absolutely no site contamination using our product for this particular application. We've done a lot of work for Caltrans over the years, all throughout the state. This was an interesting one down in San Diego along the 805 corridor. A contractor who is responsible for widening the freeway also has to identify any culverts that need to be repaired, replaced, or rehabilitated. This was a 36-inch diameter application. What's good about it, as you can see, the profile was on the shoulder of the highway. We did not have to do any lane closures. The equipment was all had and carried down to that open area there, was reassembled, and the liner was installed from off-road, and the termination structure was a 2-foot by 3-foot catch basin somewhere in the middle of the 805 freeway. So Caltrans was quite pleased with the results of this project. And again, as you saw from our SPR TF projects, internationally we've installed almost 500,000 feet of liner all throughout the world here. And this just gives you a great overview on the remote access capabilities of our equipment. The profile truck is quite a distance away. The equipment was hand carried down, assembled at the inlet location. Profile snaked down over the ground, and the operators were able to install our liner at a very difficult location. And with this, I'm going to turn this over to Chris for the SPR TMO review of Kansas City.
Great, thanks, Jackie. The next project is a larger diameter project for the city of Kansas City and Kansas City Water Services. This 114-inch circular brick pipe provided some obstacles for rehabilitation that Spiral Wound was able to solve. Starting with depths of 35 feet to the surface, multiple changes in diameter due to deflection, and 4 lanes of heavy traffic that had to be negotiated. After considering these obstacles, a 100-inch liner was selected with 990 feet of pipe to be repaired. Our Spiral Wound installer, SAK Construction, began this project in August of 2014. In addition to the obstacles that were discussed in the prior slide, SAK also had to deal with 2 tight opposite 90-degree sections of pipe, as you can see by the as-built drawing on the left. SAK was able to use the FlexiPro profile to mechanically line these bends without the need for additional access points or manned entry. This project was completed on time, within budget, and traffic control was limited to 1 lane closure for less than 2 weeks. Our most recent large diameter project that was completed in August of 2019 by Ruby Collins Incorporated out of Atlanta, Georgia, was the Peachtree Creek Trunk Sewer Stabilization Project for the City of Atlanta. This project represents the largest spiral wound project ever in the United States, as over 10,000 linear feet of liner was installed. The 90-inch arch concrete sewer had been exhibiting major signs of deterioration and infiltration, which became more of an issue due to stormwater surcharges, creating overflows within the existing system. During the design process, a fully structural 82-inch round liner was selected to rehab this pipe. As the liner met the fully deteriorated design standard under ASTM F1741-18, a cellular grout was used to fill the annular space. Due to the amount of existing flow within the pipeline, a combination of internal bypassing and flow management at the pumping station allowed the lining to continue during normal flow days. During days when the bypass was not enough to safely line the pipes, the crews left the pipe, bolted the equipment in place, then returned to lining once the high flows subsided. In addition to the bends that were done on the first slides, in the second slide, you can also see the simple bracing system used during the grouting process, as well as the everyday flows during the lining. As the lining progressed towards the pumping station, Ruby Collins crews were able to complete the lining with flows up to their knees. The lining portion of this project was completed in a little over 10 months. And that concludes our case studies. So I'm going to turn it back over to Ryan as we look to summarize and wrap up our presentation.
All right, thank you, Chris. And like Chris said, we will wrap up with a summary of this presentation. As you can see the summary bullet points on this current slide, spiral wound rehabilitation is a fully structural solution for diameters between 6 inches to over 200 inches. We have over 4 million feet installed in North America. It's a mechanical installation process that is entirely trenchless, and spiral wound rehab is capable of being installed in live flow conditions, typically without bypassing. We're going to leave those bullet points, those key things to take away, on the screen as we now transition into the final Q&A session. And please remember to feel free to continue to submit questions during this Q&A, and we'll try to get to them. If we do not have enough time to answer your questions here, we will make sure to reach out to you after this webinar. So with that, I'll ask my first question. When there's a defect in the pipe when using static or the traverse winding method, how do you fix this?
I can take that, Ryan. First of all, prior to installation, we're going to identify any defects that cannot be navigated by the equipment and the installation process. Those will be repaired prior to winding. If a defect appears during the installation, we will stop the winding, correct the problem, and then we'll continue to wind in the liner.
All right, thank you, Jackie. Our next question is, Sekisui liners have a continuous spiral seam. What post-rehabilitation testing is done to verify the liners were installed correctly and that there will be no infiltration or root intrusion between the locks?
Ryan, ASTM F1741 outlines the post-installation verification testing, including post-CCTV or manual entry. If required by an agency, leakage testing can be done. An air test will be performed per ASTM F1741 or an exfiltration test done per F1741-7.2.1. Neither test is recommended for pipelines greater than 36 inches.
All right, thank you, Chris. And we have a question about grouting here. Maybe you can handle this one as well. For fixed diameter liners, what testing is done to verify that the annular space was grouted completely?
Sure, Ryan. Typically, a common tap test with a hammer rubber mallet is done. The amount of grout that's pumped will correlate to calculations as to how many cubic yards of grout would be required. So during that tap test, if it's determined that perhaps not enough grout was in a section or a lift near a grout port, the installer will simply remove the port, inject more grout to be sure that that particular portion of pipe is the annular space has been completely filled.
Okay, thank you, Chris. Our next question is access okay via a 23-inch clear opening of most manhole frames?
I can take that, Ryan. The answer is yes. Our machinery for our products need only a 22-inch manhole opening. Our equipment can be disassembled and then pass through the 22-inch opening and then reassembled once it's in the access chamber. So no site excavation is required.
Thank you, Jackie. Do you have to limit the grout pressures to prevent liner collapse or excessive loads?
Well, Ryan, depending on the specific gravity of the grout needed in an application, we will recommend the bracing system needed to hold the liner in place and prevent it from collapsing. In most cases, the SPR product will be steel reinforced, offering another layer of stability during the grouting process. The SPR installers will work with their grouting partners to ensure that the installation of the grout does not harm the liner.
Thank you, Chris. And we have another one about liner bracing here. Maybe you can tackle this as well. Is simple bracing used for all projects, or are there other bracing options used for projects that use structural grouts or for non-circular applications?
Yeah, Brian. Simple bracing is typically used for these types of applications, but additional bracing can be incorporated for specific projects and/or applications in order to prevent liner flotation. So depending on the type of grout used, we can provide the bracing options for those types of installations.
Okay, thank you, Chris. Here's another question. If a large storm is coming and normal/high flows need to be reintroduced to the pipe, what measures need to take place to ensure the liner is not damaged if it is in the mid-pipe segment?
I can take that, Ryan. When the high flows are one of the obstacles associated with the project, the SPR contractor will install the first bulkhead in a grouted application that will hold the liner in place during that event. The equipment will be secured in place, and then depending on which of our tight fit groutless products are used, the liner then can be installed and in place can be left there while the event occurs, with winding to resume afterwards. In some cases, the installer may choose not to install on the days when there's high water events that might occur.
All right, thank you, Jackie. Our next question is, do you have licensed contractors for each region, or are areas competitively bid?
Ryan, depending on the SPR product, there are multiple contractors operating regionally and nationally who have the ability to competitively bid projects.
All right, thank you, Chris. And maybe Jackie can handle this one. It's about typical construction footprint, and they're simply asking, what is the typical construction footprint for a spiral wound project?
It's a very small construction footprint, and typically we recommend having a 12-foot wide by a 36-inch long access location at both the upstream and downstream structures. And this would be more than sufficient for having the CCTV truck, the profile, and the equipment, and for the workers to work safely in that location.
Great, thank you, Jackie. And I think we have time for one more question here, and it's kind of a two-parter. Maybe you both can tackle it. We'll see how that goes. Are spiral wound liners cost competitive versus other trenchless technologies? What are the advantages of spiral wound lining compared to cured in place pipes, CIPP?
Chris, do you want to start, and then I will add to it?
Sure, that's fine. Our liners are always very competitive, especially when you consider the constructability advantages, including little to no bypassing and no access pits being required. And Jackie, we know that some of those benefits would include.
Oh yeah, absolutely. Well, first of all, the live flow installation is very important, and as how many of you know that how often the cost of bypassing sometimes can be more than actually the liner itself. So the ability to install in live flow with little to no bypass is definitely a benefit. Mechanical installation process, as we discussed, you have consistent liner size and material properties. No post-installation non-compliances because the material or the liner thickness did not meet spec. There's no heat involved, so again, we have no liner shrinkage issues and no contamination. We discussed the small construction footprint, very, very important. And the ability to stop and start the installation process to adjust for corrections, whether it's a problem, there's debris on the hose pipe, or there's a sudden rain or storm event that we have to temporarily abandon. We have a lot of flexibility in the construction process in order to be able to install our liners.
Great. Thank you, Chris and Jackie. And we'd like to thank everybody for submitting those questions. And again, if we didn't get to you right now, we will after the presentation. We encourage you to check out our website and videos to learn more about the spiral wound process. We have basic spiral wound education videos, as well as actual footage from projects. And we can be contacted through our website as well if you have any additional questions. We really hope that you enjoyed this presentation, and we thank you for joining.